Chapter 1 Introduction to Physics. What is physics? Let us first answer, what is nature? Nature is things that we see around us, things that we cannot see, but we know that something is there, or events that happen around us. The collection of every such things and events is nature. We observe that we can see in the light, and rainbow has 7 colors. Fire hurts, it burns. Things fall on the earth. The sun feels warmer than the moon. These observations raise questions. Why do we see only in the light, but not in the dark? Why the rainbow has only 7 colors? Why does fire hurt so much? Why do things fall on the ground and not fly away? Why does a moving object eventually stops? Why does rubbing wood for some time creates fire? For majority of human history, we did not know the answers to these questions. The discipline of study in which the focus is to find answers to such questions related to nature is physics. It wasn't clear from the start that there are only a few ideas that can be used to explain every event and properties of objects. We call these ideas laws and principles. The goal of physics then becomes discovering laws that can be used to explain any situation in real life. For example, the same law of gravitation explains why everything thrown up falls back on the ground, why the moon is orbiting the earth, and why the earth is orbiting the sun. Light is a wave. It has many components. During rainfall, at some specific angles, raindrops act like a prism that separates these components, and we see 7 colors of the rainbow. Every moving object stops eventually due to friction. Objects are made up of atoms that are constantly moving. Faster the motion of atoms, hotter the object feels. Fire feels hotter because it increases the speed of atoms in our body. We see light when something is burning because during burning, electrons in the atom jump from one state to another state. When a jump happens, a photon is emitted that we see as light. It is because of our understanding of the laws of nature that we have seen so much technological innovations. So how can we learn these laws and invent something new for ourselves? As stated earlier, there are only a handful of laws that we need to learn. Look at them for yourself. So here, this is the Dirac equation. This is the Einstein's field equation. This is the quantum electrodynamic action. Similarly, electroweak force has these complex equations. Very likely, these equations do not make any sense. This is the nature of the quest of seeking a smaller and a smaller set of equations that can explain everything. We need to introduce newer concepts that have wider applicability. This implies more abstract mathematics. This makes learning these laws harder. That is why we do not start with above equations. Instead, at first, we learn simpler versions of these laws that have reduced validity. That is, they do not apply in all situations. But at the same time, we introduce mathematical concepts for higher level of sophistication, and we slowly level up towards this understanding these equations. Because we are dealing with special scenarios at first, physics is learned by dividing into various groups like mechanics, thermodynamics, electromagnetism, optics, and modern physics. Let us briefly visit what these groups are. Mechanics. A large number of properties of objects and events can be explained by observing how objects and its components are moving. In mechanics, we learn about Newton's laws of motion. We will learn how to apply these laws to predict position, velocity, and acceleration of an object at any point of time. In thermodynamics, thermodynamics concerns with temperature of an object. We will learn about how gases behave under various conditions like pressure, volume, and temperature, how heat is transferred via conduction and radiation. We will also learn how thermodynamic processes can be explained by a motion of atoms. That is, mechanics can explain every thermodynamic process. Electromagnetism. There are two types of forces linked to charged particles: electric force and magnetic force. In fact, these forces are related to each other. Charged particles create what we call electric field. But if they are under motion, they also create magnetic field. Changes in electric and magnetic fields with time creates electromagnetic waves. Light is an electromagnetic wave. Optics. In optics, we focus on properties of light. Light travels in a straight line. It is reflected by mirrors and bent by transparent material. We study geometry of these events. When light passes through small holes, it spreads and behaves like ripples in water. In modern physics, we study about the structure of atoms, X-rays, photoelectric effect, semiconductors, and nucleus. Physics is fun. It has answers to questions related to real world. Its knowledge is essential for our survival and progress. Our approach will be systematic. Study materials, practice questions, and mock tests will be available on webdut.com/IIT Physics. Thank you.